Let's move up a level in our hierarchy of motion. We've done displacement, we've done velocity, now it's acceleration. We want to come up with some conventions for the sign of the angular acceleration. So here's our definition of angular acceleration, change in angular velocity per time. Now there's going to be four cases here, all similar to what we did with linear acceleration. Can you figure them out? Well, here's a hint. For linear acceleration, if an object's velocity is increasing in the same direction as its displacement, the acceleration will be positive, no matter which direction your displacement is. If the object's velocity is decreasing in that direction, then its acceleration is negative. So work on that a little bit before you go on to the next slide, please. Here are the four cases, and we're using the definition of alpha is the change in angular velocity over time. Let's put a little picture here to help us figure this out. We'll start with the linear. So if I'm here on a line, we typically say to the right is positive, to the left is negative. So if I have an object moving in this direction, and it increases its velocity, so it starts at maybe 2 meters per second and then goes to 4 meters per second. Well, the final velocity minus initial would be 4 minus 2 over the time. That will give us a positive acceleration. If we were to slow down, that would be a negative acceleration. If we're going in the opposite direction, okay, and let's say we started at a negative 2 meters per second and increase the magnitude of that to negative 4. We're speeding up. What kind of acceleration would that be? Well, you have your final velocity, which is negative 4. Negative 4 minus a negative 2 gives you a positive acceleration. Excuse me, negative acceleration, of course. It would be negative 2. So if you're increasing your velocity this way, that's a negative acceleration. If you're slowing down in this direction, you would have a positive acceleration. Same thing works for the circle. You just kind of bend this line into a circle. So if I have an omega here, let's say I'm moving in a counterclockwise direction, I increase omega, alpha would be positive. If I decrease omega, that would be a negative angular acceleration. Now, if I'm going in the clockwise direction here, that is a negative direction. That's how we defined it. So if we're going to increase omega, I will have a negative angular acceleration, just like we had in this case here, the bottom case here with the linear. And conversely, if I'm decreasing, that means I have a positive angular acceleration. So a lot of stuff on this slide. So the best way now is to take a couple minutes, assign some arbitrary values of velocity and angular velocity, take the delta, which is always final minus initial, and see what sign you get and verify that this is correct.